Good evening, RDs and RDs to be. Welcome to RD Exam Ready Live. My name is Zach Caseberg. I'm your tutor, your coach, your guide along the path to passing the RD exam. And my biggest passion is to help students just like yourself to know a little bit more about how to pass the CDR exam. And if that sounds like you, then hey, you are in the right place. Tonight, we're going to have a nice live free session for you. So if you're a student that's joining us, welcome. We're always happy to have you in our group here. And we're going to take a session to go through some food science a little bit. I'll talk a little more about the topics that I chose for tonight. It's not going to be your full comprehensive food science, but it's going to be a couple topics that I kind of picked and chose for us to do tonight. And we'll go through some practice questions as well. To get your most use out of this session, here's what I really recommend. You have that chat function that's down there that you can use to communicate with me if you'd like to. That's a good spot where you can drop in questions, you need clarity on something, you have a comment or something really good to share with other students. I want you to put that in at that point there. You can put that at any time because I want to see those so I can make sure I get those addressed. The other point I want to make is we're a nice, welcoming group. So if you feel a little hesitant to share anything about yourself or about your journey or things you're struggling with, I would say don't be, because we're all coming in from different levels of the spectrum here. And if you have a question about something, chances are there's a student just like you who has one as well. So let's get into food science. I really want to see you all communicate through the chat to let me know how we're doing with these topics and to kind of go through a little bit about what we're going to do tonight. When it comes to food science, I was taking a look at our kind of our lesson plan tonight. And one thing that I was thinking about was I was like, well, I can teach them everything about food science head to toe, or I can focus on some of those weaker points that I think students struggle with. And I chose the second. Here's why. I can't tell you how many times I've taught, grades of fresh fruits and vegetables or grades of meat and poultry. While I know that's something that all of us need to know for the exam, to be honest, if I'm teaching you that, it's just me teaching and lecturing a little bit, just saying, here's information you need to know. Whereas a lot of you should take that as I need to do some more self study. If I need to know like grades of fresh fruits and vegetables, or I need to know grades of meat and understand that, that's going to take some self study work, not just a session with me. But what I can help with is maybe things that you've struggled understanding along the way. Or maybe you don't feel like you have a good grasp over a memory trick or anything to help you to go through these food science topics. That's what I'd like to help you with tonight. So we're going to go through this lesson that I planned for us here. I really want to see interaction through the chat function. So let me know what your best answer is. Don't be afraid to be wrong. Keep in mind, there's just a little delay as to when your answer comes through and when I'll see it. So we'll go through those together and kind of give you some topics. But the big point of tonight is to test your knowledge. So I'm hopeful that we're going to do that together. If you give me just a moment, we're going to get set up for our screen here. Sorry, everyone. I'm sorry about that delay there, really quick. You probably couldn't hear much about what I was saying there. What I was going to say is for this first learning plan, what we're going to walk through is we're going to go through and we're going to do this first topic of water. So, what we're going to do is I've given you a first blank here to say that water is a blank molecule. What I'd like you to do in the chat is let me know what that blank is going to be. Now, I've given you that definition right there of what you're going to go through. So, go ahead and take a look there. Water is a blank molecule. Now, this would mean it's both positively and negatively charged ends. What do we call a molecule that has both positive and negatively charged ends? What is that? Absolutely. Great answers in the chat dropped here, which would be that this would be a polar molecule. And that's one thing you always have to remember about water because its polarity is actually very significant to what it is. Everything from how water reacts with things helps with it being polar. How water kind of flows and stays on the edge of a glass but doesn't fall over, right? That surface tension. That's an example of its polarity and how it contributes. When something has both positive and negatively strong ends, it makes it a very strong molecule that can do a lot of things. Now, let me know in the chat, and I know a lot of you have this in your head, but remind me, what's the pH of water there? Go ahead and drop that into the chat right there for me if you know about the number pH. I put neutral here, is what I put in there. A lot of students might say something like 7.35, but just reminding yourself that that's about the pH of the body, so pretty close. But what's the actual pH of water itself? Well, that would be 7, right? So 7 is what that's going to be for that there. Good, nice easy basics that we're kind of starting with right here. So 7.0 of water, meaning it has both an equal amount of hydrogen and hydroxide kind of ions there. Very good, everyone. Now, we're going to talk about a few functions of water. It has a multitude, but I picked three ones that I didn't think all of us would be as familiar with. One of them we're definitely familiar with here, though. So, the fact that water serves as the universal blank. It acts to dissolve other substances. What do we call that when something is really good at dissolving other substances or solutes? What is the term we use for what water is? It's the universal, say it with me, the universal solvent, right? The universal solvent is what water is. Very good. Very good, everyone. So, meaning that's why it's so good at, breaking down things in the body as a universal solvent, why it's so good at mixing with water and sugar and salt, is it being the universal solvent there. Now, I'm going to kind of zoom in a little bit here. Hopefully, it seems like you can all see that pretty well. What I've kind of drawn out here is we've got this little chemical reaction here, chemical reaction occurring here, where I have a sucrose molecule. Sucrose is a disaccharide, meaning two sugar molecules, two monos put together, right? Sucrose in this diagram is breaking into glucose and fructose, its monosaccharides. Water is causing that sucrose to break down to the glucose and the fructose. And this is another term for a function of water that we see here. Can you tell me what would be the best word that would describe what's happening in this diagram here? To help you a little bit, one thing that I know is happening is there's a breakage of a bond happening here. Whenever there's breakage of a bond, I would know that my suffix would be lysis, right? To break something, lysis. So maybe you can help me about what that prefix would be for that lysis there. Addition of water, hydrolysis, that's going to be hydrolysis or hydrolysis, as we also call it there. So the fact that water is very good at chemically breaking things in the body too. It does this all the time with different macronutrients in the body. When we're trying to break things for absorption, it's breaking things and helping us to do that all the time. So water serves a great job through the use of hydrolysis as well. And I've got another food science point for you here. Water also can change the freezing or boiling point through ionization reactions. Now, When I hear ionization reactions, everyone, I get a little scared. It's one of those terms that I'm like, what's that mean? Do I have to know it? Not necessarily. Here's what I want you to understand about it though. If you've ever heard of the fact that we can add like sugar or salt to things like ice cream, right? If I add sugar to ice cream, it's going to alter the freezing point of it. And that's what water is doing in that point. It can interfere and it can disrupt crystals from forming a little bit there. So it can change the freezing point or boiling point through what it reacts with. So if you put it in a sugar substance, it may change the point at which that item would freeze or boil based on how water acts with these different things. I thought those were three functions that we're somewhat familiar with, but we haven't really stated out loud, and I thought they would be just three great ones to start with there. Okay, I don't imagine there's going to be much questions on this first slide. If there is, I want students to feel free. Let me know what questions you may have, and I'm going to look out for them in the chat. Now, here's another piece straight up knowledge for the RD exam here. Water numbers to remember. For some of us, we've seen this in so many questions, it's like tattooed in our mind, right? But sometimes a lot of us struggle. If we've taken breaks in studying, this tends to be something we forget. So if you're kind of in that phase, this might be a good little assessment for you here. So, let's start with this, students. I'm going to start with our first question over here on the left. I think a lot of you can tell me this, but if you can't, try to work through it on your own. The boiling point of water is blank degrees Fahrenheit. What I start to look for is certain numbers that stick in my brain just through repetition and through talking through it, or I'll go through a bit of kind of reasoning to get myself there, right? So if you know what you think it is for the best answer here, you can feel free to drop it into the chat. Good. Yep. So I see a lot of answers rolling in here. That's going to be our 212 degrees. Just to remind you, that's a number I want you to get nice and stuck in your head is 212. Okay. 212. Couple memory tricks for you. Some of you, for instance, might know what the temperature range is on a thermometer, a bimetallic thermometer. A bimetallic thermometer, for instance, needs to be between 0 and 220 degrees. Well, here's why. Because it needs to be able to detect the boiling point of water at 212 plus a little bit above that, as you can see. So that's kind of a good example of like, hey, here's numbers that we see repeating a little bit is those 212, 220, 0 degrees. So you can kind of keep those in your mind a little bit as you go through. Okay. And if you need a sillier memory trick, at the bottom here, I just said 212 is hot as hell. So I'm going to pretend that 12 and hell rhyme or they're close enough. But yeah, I would consider that to be a very high temperature, for instance. Looking great, folks. Now, with the freezing point here, here's one memory trick. If you are someone who lives in anywhere where it snows, you likely should know what the freezing point of water is because you know about when you need to start preparing for snow. So let's take a look. It says Frosty the Snowman appears at what temperature? AKA, what is the freezing point of water, folks? At what point am I going to see Frosty? When am I going to see Mr. Frosty, huh? Well, I know I'm going to see him right around when it starts snowing. If you live somewhere cold, you'll know that that's going to be 32 degrees. So 32 degrees is when we're going to start seeing things from water turn to ice. Okay. Saw this fact today. The price of the first Wendy's Frosty was 32 cents. So you can think of Frosty, 32, and you can kind of think of that here. Yep. Perfect, perfect. All right, love it, everyone. So, yes, this is just good numbers to stick in your head because if they give you this question, it's a softball. Like you got this thing all day. there's not much more to say on this boiling point other than this next point that I want to talk about. Here's something I chose intentionally, which is high altitude cooking, because I know this has confused students that I've worked with before. And it makes a lot of sense because it is a little bit like what? It's like as you're going higher in the sky, the boiling point is going down, everything's like opposite in your brain, and makes it difficult to sort through the information because one part's going this way and one part's going the other way. Okay, so let's work through this together and make sure we have a good understanding of this. At higher altitudes, here's the key point to take. At higher altitudes, your boiling point will decrease. Okay, so the higher I go up in the sky, the lower the boiling point will be, and that's due to the air being thinner, less atmospheric pressure. It's less work to get that water to the boiling point at higher altitudes. It's easier to reach the boiling point. It won't go to 212. So I gave an example like a fake number. I said, let's pretend it's 200 degrees boiling point at the top of the mountain, but at the bottom of the mountain, it's 212 degrees. Okay. Makes sense. Make sure you understand that piece first. And if you have questions about it, please drop them in. And here's the other point. So, when you're at those higher altitudes, when we're at those higher altitudes there, because I want you to picture it like an oven, okay? So let's say I set my oven to 200 degrees instead of 212. Well, in that instance, it's going to take me longer to cook my foods if I put them in an oven at 200 versus an oven that's at 212. Does that make sense? So, because the boiling point of water, because the water is boiling at a lower boiling point, you have to cook things longer because it's almost like you put it in an oven that's at a lower temperature. Okay. And here's the other piece: moisture evaporates quicker. And I'm going to ask you to drop into the chat. Think critically for me here. Why is the moisture evaporating quicker? I'm going to let you all drop that into the chat and we'll come back to that in a second. When we were down at the base of the mountain, because the boiling point is 212, it's like we put it in an oven that's 212 degrees. So things are going to cook faster at that higher temperature versus at the top where it was going to cook lower temperature. Okay. Good. So the reason for that moisture evaporating quicker is because we're reaching that boiling point much quicker as well, right? So if I continue boiling something, we're going to lose that gas. We're going to lose that dispersion there as we go through it. Exactly. Another point I saw that I should have added in here was that at higher altitudes, we get increased leavening. Okay. So increased leavening occurs, let's say. So things rise higher and faster at higher altitudes. Probably less work for it to raise up with the less atmospheric pressure up there. Okay, so I'm going to take a pause for just questions on higher altitude cooking right now, and then we'll move on from that point. I did want to jump into this question in the chat. Are we going to need to remember the Celsius conversions? I feel like they're going to give you both. I feel like they're not going to trick you and be like only Celsius, right? Like that's not really the point of what they're trying to do. Because then, for instance, they would want you to know the Celsius for a fever, right? If you need to know kind of around what a temperature might be for a fever of like 100 degrees and knowing that I need to give increased nutrition because of a fever, well, they would make you do the same with Celsius, right? And I don't think they're ever going to do that. So if you stick with Fahrenheit, I think you're going to be safe. I feel confident in that. All right. I'm not seeing any questions in the chat about high altitude cooking, which means you all understand it perfectly, hopefully going here on out. Come back to this graphic if you'd like. It's going to be a good thing to probably refer to just to be like, okay, here I'm up here, what occurs, and down here. And hopefully it sticks with you. That's the goal. All right, folks, we have another activity here. I'm going to introduce the activity and then I'll get to Larissa's question in the chat here. Water activity exercise. So, water activity, I want you to think back and see what you remember. And I've got these foods here. So, I've got jam, I've got a fishy, I've got, let's say, a fresh fish. I have a cracker, a marshmallow, and I have cheese. If you would, place them in order from highest to lowest in the chat of what you think is going to be the best for that there. Okay. Okay. While you're all working on that, I'm just going to answer some of these. Oh, sorry about that. Ebony, so the between the cracker and the cheese, that's the marshmallow. I knew someone was gonna ask that and be like, what is that, Zach? Marshmallow? Yeah. Okay, I see some answers roll into the chat there. I'm gonna give you all just 15, 20 more seconds to let you work on those. Remember, just practicing here. Highest to lowest. Okay. Dude. Okay. Good. Samantha, I just responded to you. Sorry for the spelling errors there. Okay. So let's go through and let's kind of sort through what we think is going to be highest to lowest. So when we think of water activity, we think of the fact of like wet foods. Okay. The foods that have the highest water activity would be the wettest of foods. The ones with the lowest water activity would be the driest of foods, for instance, here. So as we kind of look at this, let's kind of sort through. I took a couple references from some textbooks. I went and did some research online on some different universities that have posted just some of the data for water activity, and these were common foods I picked. So, um, really what I want you to take for the exam is just critically thinking. So if you were like able to get most of these in order but you messed up one, that's fine. You're going to be fine for exam day. It's just making sure you understood what was on the high scale versus the low scale. Okay. So we're going to start with what our highest scale was. And this might surprise a lot of you when it comes to this, but our highest of the highest here was our fishy. Okay. So fish is going to be your highest water activity. And so that's going to be those types of things that you think of there, like meats, like poultry, like fresh fish. These are things that have a high amount of water, not only on the outside of them, but there's a lot of water stored within that muscle, within the actual macros and the tissues. There's tons of water stored in there that we don't think of. So when you think of highest water activity, you're probably going to be thinking things like fish is going to be a good example there, for instance. Okay. So I saw a lot of those people there. That was pretty good. Of these next ones, what I would pick as our next one, let me move this just a little bit. I'm going to pick the jam, and I'm going to actually put it next there. And I'm going to check my research as we're doing it. But what I had on the table, it would depend on the cheese, certainly, right? But when it comes to this, the next item they have down that would be the next fit would be cheese. Okay. So cheese would be maybe the next one. I think it would totally depend on like the type of cheese that you chose, for instance. But that being said, they kind of said that like cheese spread or cheeses, things like that would be kind of your best fit for your next one here for just different water activities of those different foods. So, cheeses, cured meats, evaporated milk, those would all be things that would fit pretty close to that of your meat products there. Okay. Good. The next one here, I think we would all agree, would probably be our jam. Okay. And the reason we'd say jam is remember in the jam, like a strawberry jam, you have a lot of water activity within the strawberries themselves. And also, you probably added water to do it. So even if I scoop up some strawberry jam on a spoon, I don't know, it's pretty wet, right? It's pretty wet. For instance, jam has a water activity of about zero point 0.7, fish has a water activity of about 1.0. Okay. So it's not that far from that of fish, but it's going to be less water activity. And then for our last two, I'm going to sort these out. Marshmallows will be the next one, followed by the cracker, would be the one after that. Okay. So in highest to lowest, it would be fish, cheese, jam, marshmallows, and then the cracker. Good. And I saw a lot of us have most of those in the right order there. It seemed like a lot of times it was just a switch up of like the jam and the fish, which that naturally makes sense. A lot of us would think the jam would be the wetter of the two. And then just understanding like how dry a cracker is, right? It's definitely going to be on the lower level when it comes to the water activity of foods. While we all sort through that, is there questions about water activity at this time? Good. Usually a topic students understand well, but it's one of those that I'm like, man, if they give us this, this is great. I'll take these questions all day. Just need to understand how to do this exercise. And you can always just look at the meal you're eating and be like, what's the water activity of those foods if you want to be weird about it. All right, folks, we're looking good. 24 great RDs to be in the chat here. We're going to switch up to our fruits and vegetables a little bit next. It's like whole part of our job, right? So with fruits and vegetables, I got another exercise for you. What we're going to do is when I've kind of put together materials on this a little bit, I sometimes find that we know a lot of like specific things of vitamins and minerals, but sometimes we just struggle with like the broad look of like what common vitamins and minerals are just in fruits and vegetables in general. And that's actually helpful information for even things like MNT, like kidney disease, knowing the types of things that are present in fruits and vegetables that it can impact kidney disease. You can kind of see how if you look at it from a broad sense, this is just good information to know instead of always just focusing on the specifics of each one of these. So I want you to try this a little bit with me on the exercise. We can go one by one, but I think I'd rather let you all do this on your own. So I want you to kind of just walk through and circle or pick the ones you think would be primarily fitting with fruits and vegetables, meaning like when we think of fruits and vegetables, we think of these vitamins and minerals, um, or maybe somewhat. We can always justify some of them, but it might be even easier to say which ones don't fit with that too. So, however you'd like to go through it, go ahead and walk through, post in the chat what you feel like would be things that would correspond to fruits and vegetables for these vitamins and minerals. Okay. Good. And remember, don't be afraid to be wrong. It's okay. Even just try to do your best of ones that you're like, well, I know it's this. I know it's this. I don't know about the other ones. Then go with the ones that you know. That's what I always say. Go with what you know. Good. See some answers starting to roll in the chat here a little bit. So I'm going to walk through just what I kind of have in my notes as far as which ones that I really associate with that. And I'm going to kind of correspond to all of your answers here as we go through it. So, as many of you are kind of on the same page with me, starting with answer A here, vitamin C is right on the money, right? That's a softball question. Vitamin C, we automatically think of fruits and vegetables all day. Now, one thing I wanted to ask about a little bit was zinc. I don't see a lot of us mentioning zinc into the chat here, really, right? So I'm kind of agreeing with many of you. It doesn't seem like zinc is going to be a good fit, and that would be correct there. So zinc is not going to be a good fit for fruits and vegetables. Zinc is going to be really present in a lot of those meat products, oysters, seafood, shellfish. Really good sources there, but yeah, not so much in those different fruits and vegetables, unfortunately. Iron. So, the iron a little bit as we kind of go through this together. I see iron on a few of your lists there, but I don't see them on all the lists. So, I see kind of a little bit of a mix when I come to this. So, when it comes to iron, I would probably leave it off of this list. And here's my argument for that. When we think of iron-rich foods, do we automatically go to fruits and vegetables? Yes or no? I would say no. And it's not meant to argue about it, but really, when we think of good sources of iron, we're primarily going to other foods that we know are going to be a good source. Beans, for instance, are going to be a good source. We know that just poultry, meat, seafood, all good sources of iron, for instance. And as well as those leafy greens, right? We know those can have some iron in them too. But really, when we think down to it, not to make it a big debate, but I don't think people are getting most of their iron from fruits and vegetables. I'd say they're getting it from other sources. So I would leave that off the list, and I agree with many of you here. Thiamine, answer D here. As I look through all of our list, I don't see much thiamine on our list, and I very much agree with that too. Thiamine is one I would leave off the list. It's not all B vitamins I would leave off the list because some of them are present in fruits and vegetables, but for the most part, folks, say it with me. You don't have to drop it into the chat. When we think of B vitamins, we're thinking of what type of food sources? Well, our animal products, right? Our fortified foods that we see, those would be the things that would have those B vitamins, not so much just fruits and vegetables. All right, looking at answer E here, I see that in a few of our answers here. This is kind of similar to that iron discussion. There is fruits and vegetables that contain B12, but am I going to think of it as like the hot source for it? I will not. Vitamin B12 would not be a good fit for fruits and vegetables here. It's not going to be a good selection because purely vitamin B12 is mostly found in animal products, right? So we got to leave that off the list there, folks. If you are making that association in your mind, separate that and put the B12 where it belongs, okay? All right, great. Good. Looking through our answers here, I see some of our students had this next one in here, and this is going to be a yes for us. Vitamin A is going to be a yes when it comes to fruits and vegetables, especially those ones that are red, orange, yellowish in color. Those are going to be definitely present in fruits and vegetables there. So I would definitely associate the fat soluble vitamin of vitamin A being associated with that. Good. And then these last ones that I wanted to go through here a little bit. So from my text, I have magnesium is present in fruits and vegetables. Okay. So magnesium is going to be one that is present in fruits and vegetables. I don't think of fruits and vegetables as having a lot of sodium or being a very good source of sodium. And I'm sure they have a little bit, but they're not going to be the foods I necessarily think of for sodium. I would probably keep this off of my list here. Folate is one that I wanted to keep on my list because whenever I think of folate, I think of foliage. Okay. And I think of the fact that leafy greens are a great source of foliage and folate for pregnant women, for instance. So I would put that on my yes list. And then lastly, potassium. I'm going to also put this on my yes list. Potassium is present in those fruits and vegetables, and I especially think of them, folks, when I'm thinking of a kidney patient, because there's many questions that will lead and say a patient with kidney disease has high potassium after eating a large batch of fruits and vegetables. I kind of gave it away there, but as you can tell, a really common thing that can happen is people with kidney issues or hyperkalemia, if you eat too much potassium rich foods, naturally your potassium goes up. So that's what can occur with fruits and vegetables there too. Okay. Is there any debate over these? Do you all, it seems like we're all in pretty good agreement of which ones we would get rid of here with pick and choose a couple in there. But per the text, these ones I circled in green would be our probably our best fits when it comes to fruits and vegetables there. Just a nice little exercise to test that out. I think the vitamins we're all super familiar with. It's sometimes just those minerals and then electrolytes that we don't consider as much too. Okay, great. All right, I'm going to move on. I'm going to keep an eye out just for some questions in the chat here. I always love drawing this out and putting this chart together. So this is just a little reminder for you all folks. So pectin starch that's present inside fruits specifically. Pectin starch, what it'll do is it'll start out as protopectin when it's in the unripe state. Okay, so when it's in the green state. I always love the term. I say this because I just think it's helpful. I think of prototype, and I think of how the prototype is like the first. It's like your first draft is what a prototype is, right? So that's always my helpful tip for protopectin. Every time I've thought of that, I remember it for every question. It doesn't really catch me up anymore. Pectin is what will be developed out of protopectin. So as it browns, it goes through. And then finally, pectin will become pectic acid. Okay, pectic acid. So that's going to be that brown, bruised, and spotted banana in that case that you would see there. So this is just that process of how starch ripens through there. Good. Great, great. Keeping an eye out in the chat still, folks. So feel free to drop anything in that you kind of see fit. Okay, phytochemicals a little bit here. The reason I brought this up is it's always just a lot of information with food science to kind of go through. And so I kind of brought it up here a little bit so we could talk through this chart a little bit together and give you some tricks and ideas as we go through it of anything I can share. Keep in mind I've done podcast episodes on this, so if this isn't working, you can listen through there. And I'm sure there's other great tutors and other resources out there with great content out as well. Chlorophyll is a fat soluble phytochemical, and that's going to correspond to our green, right? So when we think of green beans, broccoli, green bell peppers, we're thinking of chlorophyll in that case. And chlorophyll as a compound itself, what happens is it'll become exposed to different levels of pH or heat, and it'll change into other compounds. Okay, so that's kind of what happens to it. And questions are going to lead you down in some way to say, when chlorophyll comes in contact with something acidic, what is the result? And you just have to kind of infer and have your knowledge basis set up well to know how to answer those questions. The first piece that we're going to go through here is just what happens when chlorophyll comes in presence of acid and or heat. Okay, so if we have like a just a little broccoli here. Okay, a little stalk like my broccoli growing outside. So if I take that broccoli and I expose it to acid and heat, heat is pretty self-explanatory, but I would like you to let me know in the chat what acids I could think of so I can think of what it would look like in a question, right? So if you're able to list me out a couple of acids, like one or two that we see in cooking, that would be a good thing just to kind of remember for yourself there too. When that acid and heat comes into contact with that there, it's going to take that broccoli and it's going to turn it into a very ugly color. If you've heard me talking about this before, I always talk about like I have a distinct memory in my mind of being in public school and during public school, I remember just like always seeing the canned green beans that they would leave on the line. We were always in the last lunch. So the green beans would always turn to this like olive brown color. And that olive brown color is your chlorophyll degrading into pheophytin. This is helpful for at home too. So that's when we're giving excess heat, excess acid, like that of vinegar or lemon juice. Thank you, Laura Ann. And so it's going to then degrade that to that pheophytin. You know my silly trick probably that I always think of pheophytin means phytin, acid, and heat. So I was thinking of this little like ugly olive brown guy that's like fighting off acid and fighting off heat, fighting them off together a little bit there. So pheophytin. The other side is when we have a base. Okay, so if I take that broccoli that we were using earlier, and I take that broccoli and I expose it to a base like that of, well, usually baking soda, it actually turns to the opposite. It turns to a very nice, vibrant color. A very nice, vibrant color. And that vibrant color is what we call chlorophyllin. Chlorophyllin is what we call that compound. And chlorophyllin, folks, is chillin' like a villain. So he's just like chilling out. He's got shades on. He's hanging. He's wearing bright colors. Okay, chilling like a villain. So that's chlorophyll in there. Bright, vibrant, flashy is what you see there. So you're just using this knowledge to then apply to each ones of these phytochemicals, right? The nice part is not all of them require any changes. So let's take a look at our acid and heat with that of a carotenoid. When we say carotenoid, many of you are going to think of carrots. Keeping in mind also, it's going to be your red bell peppers. It's going to be your summer squash. It's going to be those red, orange, yellows that all fit into there. Red, orange, yellows. Okay, good. So the nice part is if you can all remember, if you, when you cook at home, if you cook and roast some carrots, kind of like I do all the time when I don't know what to cook, I'll just roast some carrots and say I had a vegetable. But when I do that, and I cook my carrots, when I cook them, maybe with some acid or excess heat, luckily enough, after that, there is no change. So that's the cool thing about carotenoids. They're very, very stable to that of acid and heat and base. They don't change in any of these circumstances. They might brown a little bit, but other than that, they're not going to change. Good. I left up here a list of those carotenoids that fit within there. So we have carotene, lycopene, xanthophyll, lutein, zeaxanthin. I would just recommend knowing some good sources of those. And if you check out the episode I did on that, I'm sure I give examples of each of those too. Flavonoids, that's going to be a water soluble here. And with flavonoids, we're going to have our anthocyanins is going to be one category of these that we'll start with. Anthocyanins are going to be everything that I think of as being cyan. That's usually what I think of as the color cyan, like cyan blue. Okay. Um, and hey, so let's use blueberries. We'll just use lots of blueberries here. Definitely a nice cyan, anthocyanin type food. So when I take blueberries, or let's say I take like red cabbage or eggplant, maybe something like that. Hopefully you did a lab like this. I know not all students did a lab like this in college, but if you did a lab like this in a food science class, it might have been that you would have used something like purple cabbage and then exposed it to an acid to see how it changed color, and then a base to see how it changed color. That's kind of a common lab that people did. If I take my blueberries and I expose them to acid or heat, they're going to change colors. They're going to change into a red color. Okay, so I think of fire, I think of heat, and I think of red in that case. If I take my blueberries and I expose them to a base, they're actually going to turn to a deeper and bluer color in that case. So they're going to turn, let's just do like this blue to show a different blue color there. And I always think of base equals blue. B and B. I always associate those two together. It's helped me with lots of these. Okay. Now, moving on to our last class of these, which are flavonoids. So, flavonoids, anthocyanthins, that's our next one here. For anthocyanthins, what I always think of is the lack of color. So, I always think of that X that's on here, anthocyanin, and I think of no color because these are going to be things that lack color. It's going to be things like cauliflower, onions, garlic. Those are going to be your sources of anthocyanins. When you expose them to acid or heat, luckily enough, not a big change that occurs there. If you do cook like an onion, for instance, if you cook an onion inside of a aluminum pan, or if you cook it with a base, for instance, and it's going to take that onion and it's going to turn it to a yellowish color. Okay, so it's going to take it and it's going to make it yellow. So that might be why at times that you'll see when you cook onions, they turn to like a yellowish color in the pan. That is due to a reaction that that anthocyanin is having with the pan itself. Okay. So as I said, just come up with nice little tricks that work for you for how you want to remember these phytochemicals. But this is a big piece of food science here as well. All right, looking good, folks. I'm going to keep an eye out for answers in the chat just for a few more seconds here. And then we'll start moving on to our next topic. Okay. Another exercise for all of you. Hopefully you're enjoying doing this instead of just straight traditional teaching methods. I want to give you fun things to try, want you to kind of test things out a little bit for yourself. So I've got this little grain chart here, and I want you to match the correct physical property and nutrients to the correct part of the grain. Okay. So that's what I kind of want you to do. I want you to start in kind of, you can do it on your own, or actually, let's do this together. That would seem like a good idea, right? So let's start with our bran. Do you think the bran is going to be the brown part, the white part, or the orange part? Work in your mind and let me know which one fits with the bran. Which of these was going to be your bran in this case? Which one do you think would be the bran? Okay. So our bran is going to be the brown area, right? So that's going to be the brown area for the bran. Good. And then, folks, give me our next ones and sort out B and C. Is B going to be the white part or is B going to be the orange part? And then do the same for C. Is C going to be the white part or is C going to be the orange part? Which is which in this case that you think of? Which do you think? Okay. Good. I see some great answers rolling in here. Really good. So for this next one, endosperm, that's going to be our white part here. And then the germ is going to be this orange part here. Good. Very good. Now let's do this same type of application with these nutrients here. This is going to be a bit harder for you all, and I want us to kind of work through it a little bit together if you don't mind here. Now, let's start with answer D. So the starch, a little protein, and B, vitamins. I wonder if you know that off the top of your head, which would just fit with that case. Here's what I know is that this part of the grain would be the largest part of the grain. The largest like volume or amount of the grain would be of that starch component there. Um, and I don't think it would be that orange part. The germ does not seem like it would be a good fit because it only makes up a very small portion of that, right? So, what do you all think? D would fit with which of these more than likely? The bran, endosperm, or germ, A, B, or C? Okay, good. So I see some answers rolling in here. So our starch, a little protein, and B vitamins is going to be found inside of that endosperm that you can see there, but just by that white quality of it, it's starchy looking, right? Oh, sorry, put that to the wrong one. Pardon me. For E, our fat, protein, fat, and water soluble vitamins. Which one would that be? Okay. Here's my little clue. I kind of think of this as like if I have the fats, the protein, fat soluble vitamins, I almost think of this as what I call as like the yolk of the grain. This is what I kind of call this. That yolk of the grain to me that has these types of vitamins and minerals, I'm going to say that's going to be answer E in this case. Okay, so I'm going to say that's going to be the germ, is going to be that yolk of the egg. And that is, in fact, where we're going to find the fat content for a grain, the protein, and the fat and water soluble vitamins as well is going to be found in that area. Then finally, for our last one, as we can tell, fiber, B vitamins, and minerals, that's going to be your bran, of course, there. So bran is going to be where the fiber is found. And just to remind all of you, when we are taking a whole grain and making it into a refined grain, you are removing the bran. That's the kind of the piece there is you're removing the bran piece of it. Thank you. The bran is being removed, so the fiber is being removed. And that's kind of the main portion of that. And that's why the bread tends to be lighter in color, as well as it's the bleached flour they're using too. Cool. Hey, you were all really great at that. You're like experts on grains. That's perfect. All right, folks, we're doing good on time. We're probably going to go past the hour, just so you know here. So if some of you have to sign off, you want to come watch later, you can absolutely do that. But we're going to keep trucking along here. Um, yeah, we'll see how much we get through here. So then my next piece is I wanted to talk through amylose versus amylopectin. I can't tell you how many times that this has been a struggle with students here. And it's because one, they sound so similar, and two, you don't really know what you're supposed to study, even. So I thought I would give us a little presentation of how this really fits into food science as well, and what you're going to need to know for food science questions with it. So we're going to start with the left here. What we have first is we have our amylose. Okay, this is what we have here first. Is this is amylose. I don't need you to know each part of the chain or each different element that's being used in it. Rather, what I want you to understand is the shape of this amylose. As you can see here, it's very linear. Okay. It's similar to almost how we talk about saturated fats, about how they're very linear, right? There's kind of also some similarities with that with the amylose. Okay. So amylose is very linear, just like this. And amylopectin is its kind of twin, right? But it's its better looking twin. So amylopectin has these branched qualities. Okay, so it's branched. That's a big difference between amylose and amylopectin. And you should note that for questions because that's a really easy differentiation to make. Amylopectin is branched where amylose is linear, we would say there. If you've heard me talk about saturated fats, I've talked about how the fact that they're linear makes it very easy for them to be solid at room temperature because when something is linear, you can just stack layers on top of layers on top of layers and layers, right? It's very, very easy to like get a lot of density on things that have linear bonds. Um, but so amylose here, the fact that amylose is linear makes it a really great, great, great starch for gelling. If I need to make things into gels or gelling, it's very good to use amylose, and that's because of its linear quality. Because if I mix water into amylose starch, because it's so linear, it can actually trap the water and properly form a gel. Because it's so linear, it's almost like it's stacking and trapping it in between all the molecules. It mixes very easily like this. And that's why it's the best starch for gelling. And if you see that on a question, note that, because gelling is its best quality, I would say. Amylopectin is branched, and it actually leads things being waxy and a little bit gummy in that case. Not very smooth, starchy mixture, a very like clumpy, gummy, waxy. And that's based on it being branched. So it doesn't trap water very well, and it makes kind of your things that you mix with starch and water very viscous, not very smooth, I would say there. Amylose in a common starch of like a potato or any type of item usually makes up about 25% of the starch in that food item. And amylopectin is usually about 75% of it, too, there. I don't know if there's going to be more questions, and if you have any on it, feel free to ask. But when it comes to amylose and amylopectin, I would probably remember the points that I've listed right here for you. And then I'm just going to add in here too. I know some of us may have seen a question before that talks about the difference about how one is going to have alpha 1 4 and one's going to have alpha 1 6. I would just maybe note that alpha 1 6 bonds, these branched bonds, are specific to amylopectin only. Ooh, Lucy, can I give an example of a food of each? Well, the hard part with that, Lucy, I would say, is just because some starches have both in them. Okay. So, like a potato might have like both types in there, for instance. It said just kind of from like a preliminary search that it said like corn and cornstarch is a good example of like amylose. When I was looking in the text, it mentioned like pure regular cornstarch is a very smooth starch. When you mix it with water, it's super smooth, right? It's not very viscous. If you mix it properly, usually it mixes quite well um, with the water itself. Then it says that amylopectin could be things like potatoes, cassava, wheat, rice, barley. Kind of give some examples there. But like I said, each type of starch is present in these different starchy foods. It's just in different amounts, is what it would be. Good question, Lucy. Okay, great questions there. Now we're going to move on to cow's milk as we start wrapping this up a little bit here. Let's do that same exercise we just did with vitamins and minerals, but let's see what you can pick for cow's milk here. A tip: rely on what you know and not what you don't know. So if there's one of these that you go, oh, I don't know if that's present in it, well, then why set yourself up with it, right? Rely on the answers that you do feel confident or things that you know or not inside of it. Good. Like these answers rolling in here. I like it. So yeah, I'm going to go through and I'm going to talk through kind of what I think fits here. Um, so I'll start with this. Vitamin C. Nah, I'm not really thinking of vitamin C too much when it comes to that of milk, right? I think we can all agree we can rule that one out of our list. For zinc, as I look at your answers here, I don't see anyone mentioning zinc. So once again, none of you were tricked. Zinc is not going to be found inside cow's milk. Iron. Okay, so we didn't put iron in here. And why is that? Well, there's a couple reasons I don't think of iron with cow's milk. One reason being, there's just not iron in cow's milk, really. The second piece is you may have heard about how little kids drink way too much milk and then they end up having an iron deficiency because they're so filled up with milk and they're only drinking milk and not getting enough iron rich foods. Well, that's another reason why I would say cow's milk would not be a good fit um, for this. By the way, sorry, this says fruits and vegetables here. Milk is what we mean. So definitely not iron. Definitely not iron. Riboflavin. Riboflavin, folks, is going to be a yes for that one. Okay. So riboflavin, B2, as it's also known, that's going to be a yes for us for sure. We know that riboflavin is really present in that of milk. Okay. Vitamin B12. Vitamin B12, I'm going to put on my yes list too. We usually say that most animal products have vitamin B12. I'll include it for my yes list just with the fact of milk and dairy being on the animal products list. Vitamin A. Vitamin A, I look through our lists a little bit here. Hmm. Okay, I see it on some of our lists. I want to remind you folks, vitamin A is present inside milk. Okay, so vitamin A is a yes for milk. Milk does have vitamin A inside of it as a soluble vitamin. Okay, good. I'm going to remove magnesium. I'm going to say yes to calcium because we know that's going to be yes. And I'm also going to say yes to vitamin D. Okay. So make sure you make a note. Vitamin D looks like it was on everyone's list, but we also had vitamin A there that we'll need to remember. Reminder here, vitamin D is being added to milk here, right? So it's being fortified with vitamin D, is it not? So that's the reason why we want people to consume vitamin D because they're going to get their calcium. I'm sorry, milk. They're going to get their calcium, but they're also going to get their vitamin D. So we're fortifying it. Take a look at your milk and check it out. Then potassium. Potassium I didn't see on a lot of people's list. Let's double check. Okay. Yeah, check this out, folks. So I thought a yes for this, and it would be a yes. In milk, in 1 cup of milk, there's over 300 milligrams of potassium just in 1 cup of milk, which is a lot of potassium there. So let's make sure that's also on our list here for milk, is that it does have potassium. And that's why we have to be a little cautious of those kidney patients for that case, because milk has potassium, or really anyone with hyperkalemia probably too. Okay. Any of these up for debate with any of you folks? Love this other answer in the chat just about how iron and calcium also compete for absorption too. So that's a correct statement, just saying that they compete for that absorption. Good. All right. Good. Going to move on just for a few quick topics for you here. This is going to be more of like a critical thinking type thing a little bit. It's one that I recommend that you check out even on your stovetop as well. When you're using milk in food preparation, like let's think of sauces on a stovetop, here's a little reminder of what's happening. As you heat milk, and if you're not watching the milk will precipitate, right? It's going to kind of almost solidify and it's going to end up on the edges of your pan and on the bottom of your pan. Can't tell you how many times I have like burnt the bottom of a pan making hot cocoa or something like that, right? Because I wasn't watching it. So, what's happening is when you heat the milk, it's precipitating the way that liquid portion is precipitating, it's like evaporating onto the surface and the outside and bottom of the pan because it's so dang hot. Okay. I want you to think about how you could prevent this. Okay. How you could prevent this. So maybe I could give you a few answers to think about here, or you can think about it yourself. Could I prevent this by Adding an acid? Could I prevent this by stirring frequently? What do you think? If you had between answer A and B of how to prevent that milk from precipitating on the side and ending up on the side, maybe you've done this yourself, or this is a good signal to do it yourself a little bit. Is just go heat up some milk a little bit to see. But what would you feel would be your best fit of how you could prevent that milk, or that whey, I should say, from precipitating on the side of your pan? What do you think? Yeah. Yeah, good work, folks. Be for sure. And if you've ever tested this out, this is the best way to prevent that precipitation of milk. And I think this could be a question for sure. Is stir frequently? Frequently. Okay. Good job, folks. Really good. Now, here's another critical thinking for you here. And this one is I know I've seen a question on this before in some form. Casein is that solid form of milk protein, correct? That's something you should be aware of if you're not. Casein will curdle, okay? Curdling, solidify, and kind of coagulate in a way is a good way that I always think of it, right? Now, this can happen when times we want it to with enzymes. And it can also happen with acids too. So I want you to think about answer A and the B, okay? If I want to prevent my casein from curdling, okay, what should I do? What makes the most sense? Should I A, slowly, and let's picture A. I have a big bowl of lemon juice and I slowly pour milk into the lemon juice. Would that prevent the casein from curdling? Or the opposite, I have a big bowl of milk and I added some lemon juice to it slowly. Which do you think would prevent that curdling or that yucky solidification if we don't want it? What do you think? This is a good one I wanted to question you guys on a little bit. Okay. Good, Patrick. Good answers in the chat here, folks. Absolutely. Absolutely. So we're going to slowly add the acid to the milk, right? The milk being the higher volume, then when I add a little bit of acid, it's not going to curdle as much because it's not being overwhelmed by the acid, right? It's being slowly introduced in that case. So just in case that pops up on a question, let's remember that as well. Okay, good. I've got, yeah. Okay, cool. We've got like 3 or 4 more slides to go through here, folks. Egg structure. Work with me here. Can't really tell me much of what you think would fit well. But let's go ahead and let's put 1, 2, 3, 4, and 5. So we'll have 1, 2, 3, 4, and 5. Do this matching exercise for me here. I'm going to put then, let's put A, B, C, D, and oh, there it is, and E. Okay. All right, so you've got 1, 2, 3, 4, and 5. Sort that out for A, B, C, D, and E here. Okay. What do you think this would be our fitting for each of these? 1 is always the funkiest one a little bit here. So number 1 is going to be my Chalice, right? Number 1 is the Chalice here. And then the answer that would fit for the Chalice would be answer D as in dog. Okay, so that would be your Chalice is going to be that blue little spiral thing that acts as an anchor. It acts as an anchor to anchor down that yellow part. Okay, good. Number two is the shell. As I look through this, I would say answer B, as in boy, is going to be your shell there. The yolk, I think a lot of us know what the yolk is going to be. We've seen a yolk many a times, but if you don't, yolk is going to be number 3A there. So that yellow part of the shell, of the egg itself. Number four is going to be the air cell, and the air cell would correspond to answer E as in Edward there. So that's your air cell. And then number five is the albumin, which is your white area here, and that would be 4C in that case. Nice work, folks. Very good. Very good. Now, we're going to do a little test for you. I need you to tell me egg yolk versus egg white, which fits where? So, for let's say the fat content, I want you to put yolk or white. For vitamin A, D, and E, not for each of them. I just want you to choose one of those, yolk or white, for all of those vitamins. Niacin, riboflavin, choose one of these, yolk or white, etc., etc. So take a little look and see what kind of fits for you as it goes through there. Shouldn't be too hard. A couple of these might be a little bit of a challenge. Okay. Well, I'm going to start out with my fat content here a little bit. For the fat content, I'm going to think about where I know the most amount of fats are present inside the egg. To me, that would have to be in the yolk, correct? The yolk is definitely going to be where I find the most amount of that fat content. Vitamin A, D, and E. These are all fat soluble vitamins. To me, folks, vitamin A, D, and E would actually be found in the yolk. And that would be because it's fat soluble, and that's where most of your fats are, right? So I'm naturally thinking of those fat soluble following where your fat content would be, which makes definitely the most sense there. Niacin and riboflavin. For me, this is going to be in our white, and I can check some of my notes there, but I have down as our white is going to have that. Keeping in mind, these are water soluble, okay? And most of your water is present in that albumin there because it's so thin, runny egg whites, right? So it kind of makes sense as to why more of your water soluble is being found in the white. Cholesterol is usually found in the yolk because it's usually associated with fat. Also, this is why we always say people who eat eggs have high cholesterol, okay, with a grain of salt, as you can hear. And then finally, potassium and magnesium. These are also going to be the white here. So this will be the white. That's going to hold a lot of the potassium electrolytes, water, and minerals like magnesium there. Okay. So it seems that was a good little quiz for us. What I would always come back to is just knowing where that fat content is going to be, where that protein content is going to be, fat versus water. That's going to serve you pretty well when you're trying to differentiate which areas are going to have which vitamins or which minerals there. Good. Good. I'm just going to skip this one for right now, folks. Okay. Good. Two more exercises to finish your night. So we have a blue steak, a red steak, and a brown steak. Okay. And I need you to remind me what the terms are that are going to fit with each of these steaks. Okay. What is the term that's going to fit with each of these steaks? To give you a clue, it ends in globin. Okay, so see if that can help you out to see which is going to fit with each of these. Some of you might be really familiar with this. You've studied it in depth and you feel good with this. And some of us are like, wow, this has been such a long time, Zach. It's hard for me to remember back to that. In which case, it's a good thing we're talking through it together. Okay. So for this different pigment that we have through here, what we're talking about today is going to be myoglobin. Myoglobin, okay? Myoglobin is that red pigment that we're going to talk about here, okay? So that's going to be the red pigment. So check this out. Myoglobin. We're going to put that in the blue. And here's why, folks. When meat has not been exposed to oxygen, it's myoglobin. Okay, that's what it starts out as there. So myoglobin is when it's in this blue form that you kind of see. This happens when steak has only been recently cut or hasn't been exposed to oxygen. It's really blue because the blood that's within the steak, just like you and me, has not been oxygenated yet. It hasn't been exposed to oxygen, so it wouldn't be red, it would be blue, deoxygenated. When the steak then gets exposed, and no, you were totally right in the chat. We're doing great here. When the steak has been exposed to oxygen, we call that oxymyoglobin. Oxymyoglobin is when it's been exposed to oxygen there. Finally, as the steak continues to stay exposed to oxygen, it gets kind of brown in color. It starts looking pretty attractive. One thing in the text that mentioned this does not necessarily mean that the steak needs to be thrown out, but you're probably getting close, I would say. It's been exposed for a long time. When we get to this point, this is called metamyoglobin. Metamyoglobin. So it goes from myoglobin to blue, oxymyoglobin to red, metamyoglobin to this brown color that we see there. Okay. So come through, do a little matching, try some exercises with it, look in your fridge, get some memory tricks going, and kind of see how you can work through that too. Okay. Final exercise of your day here is smoke points. Toughie, right? A very toughy one for us to kind of go through is going to be our different smoke points. I need to refer to my textbook just to make sure that I'm giving you all the best information that I can when it comes to smoke points, okay? So if you all want, I'll just give you A, B, C, D, E, F, G. And this one down here, this is canola. This is soy. Sorry if it's too hard to see, everyone. This ghee, sesame butter, and this is olive oil, and that's an avocado. So, cool. All right, so work through that a little bit, and then we're going to just talk through these smoke points to finish our night together. Okay. I always think it's good to start with, hey, what do we know is going to be the lowest to the highest, okay? So let's start with what we think is going to be the lowest. What's going to be lowest, and this should be at least towards your lower end, is going to be butter, okay? So butter is going to be the lowest of it. Butter has a very low smoke point, and we'll talk about why, but that's going to be kind of a big one there, okay? So butter is done. The next one after this is going to be most olive oils. Okay. Olive oil has a smoke point of right around 390 to 400 degrees there, which is not very high. So the next one we would have on our list is going to be olive oil. Okay. And I'll resort these for us here. Okay. Really shortly after that is most of our vegetable oils. Okay. So most of our vegetable oils are going to be things like our soybean oil would be on there. Oh, wait, sorry. Let me back that up. Pardon me. I would probably put our canola oil as that being a vegetable oil. That's what I would probably put for there. In a lot of fryer oils that we see at like deep frying places is usually a vegetable oil of some kind, similar to canola. Okay. You're all looking great here. Then, after that point, I would put the sesame oil on there. Sesame oil has a smoke point of about 440 degrees, followed by our ghee. Ghee has a smoke point of about 485 degrees. Soybean oil, which is probably the most common type of oil that we see things fried and battered in. And then finally, your tip of the top, your highest of your highest smoke points, and I see a lot of us have that in there, is of course going to be your avocado oil. Those would be your highest smoke points here. So let's resort these together a little bit. We'll leave it just how it is a little bit and just resort. So, okay, good. So I'm just going to remove those answers for you there. Good. All right. So once again, when we start at the bottom, it's going to be butter is the lowest smoke point that we're going to have on that list. Olive oil would be shortly behind that. It's a great oil for like adding to different things, but it's not always the best one to cook in, but it has really great flavor when we add it to like vinaigrettes and things like that, right? After that, you're probably going to see your canola oil that's going to be on there. Then you're going to have your different things like sesame oil. Ghee has a very high smoke point, and then your soy and your avocado oils would be your late stage kind of there too. Okay. Excellent little exercise, and hopefully a good series of exercises for you all to go through tonight as we went through. So you all stuck around very well for the session. I'm impressed. So many of you were kind of into it and wanted to stick through the whole session. So that's always really cool for us to do. Just to sign off tonight, what I always kind of want to emphasize is these sessions are meant to be positive for you and help you to kind of grow a little bit as a student. You will not be studying forever as we go through this. But the more you're studying, the better you're getting at these topics, the more you're using process of elimination to your questions, you're putting yourself at better odds to get a question right. So I'm going to sign off for now and let you all go. Feel free to reach out to me over email with any further questions you might have. I'll let you all go at this point. But as always, happy studying to you, RD to be, and you'll hear from me soon.